After the well site has been carefully prepared to meet environmental, health, and safety standards, drilling can begin. This is an intricate operation requiring a well-planned infrastructure. A variety of processes and expert, well-trained specialists are used to bring natural gas to the surface. Chesapeake works with these experts during every aspect of the project, while strictly adhering to all individual state regulations. During the drilling process, the rig is in constant operation 24 hours a day, 7 days a week, for approximately 21 to 28 days. As an added precaution in some areas, a protective mat covers 2/3 of the pad site. Utilizing heavy-duty industrial-strength drill bits, a typical well is drilled in several stages, starting with a large diameter drill bit and then successively smaller drill bits as the drilling is advanced. After drilling each portion of the well, nested steel protective casing is cemented into place. This will protect groundwater and maintain the integrity of the well. Initially, and prior to moving in the drilling rig, a large diameter hole is drilled for the first 50 to 80 feet. Conductor casing is then cemented into place, stabilizing the ground around the drilling rig and wellhead and isolating the well from most private water wells. In the Marcellus area, the freshwater zone extends to approximately 800 feet below ground. The freshwater zone consists of porous sandstone and rock stratas containing water within the pore space of the rock. Chesapeake utilizes air drilling until the hole is advanced to an average of 100 to 200 feet below the base of the freshwater zone. This provides added protection to the freshwater zone. A series of compressors and boosters generate the air that is used to lift the rock cuttings and fresh water into steel bins. The rock cuttings are then disposed of within state guidelines and permits. The drilling equipment is retracted to the surface and stored for the second stage of drilling. To protect the integrity of the hole and to protect the surrounding deep freshwater zone, a second layer of steel casing, called surface casing, is installed and cemented inside the newly drilled hole and conductor casing. Cement is pumped down through the surface casing and up along the sides of the well to provide a proper seal. This completely isolates the well from the deepest of private or municipal water wells. A blowout preventer is installed after the surface casing has been cemented. The blowout preventer is a series of high-pressure safety valves and seals attached to the top of the casing to control well pressure and prevent surface releases. Next, a small drilling assembly is passed down through the surface casing. At the bottom of the casing, the bit drills through the float equipment and cement, continuing its journey to the natural gas target area as deep as 8,000 feet below the surface. The drilling method employed below the surface casing uses drilling mud, which is a non-hazardous mixture based on bentonite clay or synthetic thickeners. In addition to lifting the rock cuttings out of the hole, drilling mud also helps to stabilize the hole, cool the drill bit, and control downhole pressure. A few hundred feet above the target shale, the drilling assembly comes to a stop. The entire string is retracted to the surface to adjust the drilling assembly and install a special drilling tool. This tool allows Chesapeake to gradually turn the drill bit until a horizontal plane is reached. The remainder of the well is drilled in this horizontal plane while in contact with the gas-producing shale. Drilling continues horizontally through the shale at lengths greater than 4,000 feet from the point where it entered the formation. Once drilling is completed, the equipment is retracted to the surface. Then, a smaller diameter casing, called production casing, is installed throughout the total length of the well. The production casing is cemented and secured in place by pumping cement down through the end of the casing. Depending on regional geologic conditions, the cement is pumped around the outside casing wall to approximately 2,500 feet above the producing shale formation or to the surface. The cement creates a seal to ensure that formation fluids can only be produced via the production casing. After each layer of casing is installed, the well is pressure tested to ensure its integrity for continued drilling. A cross-section of the well below surface reveals several protective layers: cement, conductor casing, cement, surface casing, drilling mud, production casing, and then production tubing through which the produced gas and water will flow. 7 layers of protection. Horizontal drilling offers many advantages when compared to vertical drilling. Since horizontal wells contact more of the gas-producing shale, fewer wells are needed to optimally develop a gas field. Multiple wells can be drilled from the same pad sites. For example, development of a 1,280-acre tract of land using conventional vertical drilling techniques could require as many as 32 vertical wells, with each having its own pad site. However, one multi-well pad site with horizontal wells can effectively recover the same natural gas reserves from the 1,280-acre tract of land while reducing the overall surface disturbance by 90%.